Hello everyone, I hope all of you have elementary concept of vector, the coordinate of vector, when two vectors are parallel, and concept of position vector and section formula. Also, we have already discussed representation of vector in 2D and 3D. This session, I assume that you all are familiar with the basic concept of vector, and this dot product of vector we are going to do for class 12 mathematics students. Just the elementary concept and very simple application of dot product we are going to do today. And this dot product in mathematics will help you to revise the formula in trigonometry, some concept in geometry, and I assure you that the way we will be doing here, it is easier than what you have done in your class 9-10 classes. Let's start the concept, the definition, how the product of two vectors are defined. We are taking two vectors here, that vector A and vector B. O is the origin, theta is the angle between them. So dot product between two vectors A and B is defined as A dot B equal to mod A mod B cos theta. You can simply write A dot B equal to AB cos theta. Okay? So, vector without arrow means the modulus. So, we need not write mod A and mod B, we can write simply A and B cos theta over there. Here, theta is the angle between A and B. Okay? And this dot product of two vectors is a scalar quantity. Why? Before we do the application of dot product, or to take some important notes on it, we'll first try to realize what does A dot B mean. There are two vectors, there may be anywhere. This is say vector A. This one is the vector B. Okay, maybe situated in plane or space, wherever. When you are taking dot product between two vectors, you need to know the angle. You need to know this angle theta. Now, AB is the vector A. A dot B, you have seen that if this whole vector is B vector, this say OC represent B vector. Here we take AB equal to, we write this all these as observation, important observations. AB vector is what? A. We have taken that. OC vector we have taken as B. And the angle I told you, theta. And we have produced this one backward to meet the vector B at this point, and we have taken theta with the angle between A and B. Okay, and A dot B we write first. This is mod A, mod B, cos theta. You draw a perpendicular here. AL and BM be these two perpendiculars. BM. Now, when you are saying it is mod A mod B cos theta, so what is the effective part of A vector on B? Effective part of A on B going to be LM. This we say component. Component of A on B is equal to LM. Okay? As if this one will be lying on B, but not fully because they have different direction. The effect of A on B, if we try to take it, is this part only, LM. Now, if we draw another perpendicular here, AR, this LM is nothing but AR. Okay? LM is nothing but AR. And as this angle theta, this one going to be theta. And in this diagram, it is mod A cos theta. Because AR by AB equal to cos theta. So AR equal to AB cos theta. So mod A cos theta. LM equal to AR, which is equal to mod A cos theta. So component of A on B is mod A cos theta. Now this mod A cos theta we can write as A dot B by mod B. Okay. So we have made one very important observation that effective part of A on B, I mean component of A on B is mod A into cos theta, and which we can write A dot B by mod B. And this will say this LM is called projection also. LM is called projection. Therefore, we can write that projection of A on B is equal to A dot B that divided by mod B. Okay? Projection or component of A on B is A dot B by mod B. So dot product we have understood. And what's the actual meaning of dot product in mathematics? I told you we are doing it for mathematics only, that you have understood. A dot B can be used to find component of vector A on another vector B. Okay? Now we make some important observations, remembering all these concepts. What are those observations? Number one, we are writing this as important observations. Number one, dot product is commutative. You have done A dot B this manner. This is A, this is B, theta with the angle. We have written A dot B equal to mod A mod B cos theta. Somebody want to find B dot A. What about B dot A? This will be mod B mod A cos theta. So this will imply that A dot B equal to B dot A. So this commutative property also a mathematical property. Dot product commutative, that you need to know. Okay? It obeys commutative property. A dot B equal to B dot. Like in multiplication you have seen for two numbers, vectors also, that is valid. Number 2, it obeys associative property. What is that? That let M be a scalar and A and B are two vectors the way we have taken. Then MA dot B can be written as M A dot B. You can ask me a question, why not A dot B dot C equal to A dot B dot C? No, it will not be valid. Why? Because A dot B is going to be a scalar. C is a vector. Left hand side, some scalar into C vector. Right side, some scalar. B dot C will be scalar. That into E. Dot product is scalar quantity. So left side A dot B, when you find, it will be a scalar quantity. So it will give you a vector collinear C on the right hand side. B plus C is also a scalar. It will give you some scalar into A vector. So we can state that for three vectors not possible, this is not true. If we take M as a scalar, M dot A dot B equal to M into A dot. These concepts you need for your descriptive as well as MCQ questions. Number 3, third property, distributive property. Does it obey distributive property? Let's see. We take distributive property, if it holds, it will be of this form. A dot B plus C will be A dot B plus A dot C. This must obey the law. So we take this one as A vector. BC you can take anywhere, but we'll be taking this manner now here. B is this vector, C is this vector. O is the origin, OA is A, OB is B, and BC is C vector. Okay? Now, we want to find A dot B plus C. So in this diagram, which one is B plus C? How can you get B plus C? You all are good at triangle law. So we use triangle law here. This one going to be B plus C. Okay? So if you want to find A dot B plus C, A dot B plus C, this is what? This we can say it is projection of B plus C vector on A. Just we have done projection of the vector A on B is A dot B by mod B. Component also we have done. Component of A on B is mod A cos theta, where theta is the angle between them. I did not write theta here. I can write. If you take angle theta here, then you just write as it is commutative property B plus C dot A. This is projection of B plus C on A, which is nothing but B plus C, or you write that OC cos theta. Clear? This is going to be OC cos theta. Better you write this one in this form first. for your better understanding. That is mod B plus C mod A cos theta. This is mod A into B plus C cos theta. So B plus C cos theta is what? If you draw a perpendicular here, draw a perpendicular. CL with the perpendicular. Then this is going to be B plus C cos theta is this part, projection of B plus C on A into mod A, isn't it? So B plus C cos theta is OC cos theta into mod A. But OC cos theta, OL by OC equal to cos theta. So OL equal to OC cos theta. So this is going to be OL into mod A. Draw another perpendicular here. BM, be another perpendicular. Then you all can see that what is OL. OL is what? OM plus ML, this into mod A. But in diagram, OM is what? OM into OA is what? OM into mod A plus ML into mod A. What is OM? OM is, you can see this B vector is there. OM going to be projection of B on A. This is projection of B on A plus ML into A. ML is what? ML going to be projection of C on A. But projection of B on A, this formula is mod B, mod A, cosine of the angle between them. If you don't write the cosine of angle, simply we can say that by definition, projection of B on A is going to be, there is projection of B on A and mod A also, no? Mod A multiplied with it. Here also, mod A multiplied with it. Projection of B on A into mod A is what? It is A dot B. Projection of C on A and mod A is what? This is A dot C. All these we are applying just by remembering the definition of dot product. It is that mode of A into projection of B on A in both the cases. So you have started with A dot B plus C and you got it is equal to A dot B plus A dot C. So dot product obey distributive law also. Now we make fourth observation. If A perpendicular to B, then A dot B has to be 0 because perpendicular means theta equal to pi by 2. So mod A mod B cos theta, this has to be 0. If we go by one simple application of it, find M so that A equal to 2i mg minus 3k is perpendicular to B equal to I plus 2j plus 4k. Now, suppose you have to find A dot A. What's the result? It will be mod A Cosine of the angle between them is 0 degree. It will be mod A square. So A dot A will be mod A square. Clear? Now let us work with the three vectors I, J and K. This is your I vector, this one J and this one K. What about I dot I? This is going to be mod I squared. This is 1. What about J dot J? Mod J squared. This is 1. And K dot K also similarly 1. But if we have taken I dot J, result 0. J dot K 0. K dot I is also 0. Okay. Now, suppose we have to find A dot B when A is given to be A1 I, it's not dot here, A1 I, A2 J, A3 K, B is given to be B1 I, B2 J, B3 K. What about I dot I? That we have learned. So when you are taking dot product here, A dot B going to be A1 I, A2 J dot B1 I, now apply distributive law. This with this one, and this one. I dot I will be 1, but I dot J 0. I dot K, that is also 0. A2 B1 J dot I 0 plus A2 B2 J dot J is 1 plus A2 B3 J dot K is 0 plus A3 B1 K dot I 0, A3 B2 that is 0 plus A3 B3. So A dot B going to be A1 B1, A2 B2, A3 B3. So perpendicularity you have learned. You also have learned how A dot B can be determined when A and B are given vectors. Let us go for one very simple application. Find M so that 2I mj and I plus 2j plus k are perpendicular. To prove they are perpendicular, we'll use their dot product equal to 0. So answer will be like this. Since vectors are perpendicular, since they are perpendicular, therefore 2I mj 3k dot I plus 2j plus k has to be 0. Therefore, 2 plus 2m minus 3 should be 0, 2m 1. So, m equal to 1 by 2. One very simple application. Okay. Now, let us find simple application first in trigonometry. Application in trigo. dot product can be used to find the relation between angles and sides of a triangle. Those who have studied property of triangle in class 11, they have seen that if A be the length of side BC, B is the length of side AC, and C is the length of side opposite to angle C, then cosine rule is there. ABC are angles of triangle that we have taken. This C stands for angle. Then we can prove projection formula. That is A equal to B cos C plus C, projection formula. That is A equal to B cos C plus C cos C. I am not saying that it cannot be proved with the help of trigonometry. Definitely you have done that way. But vector method will give you one easier way to prove all this. B equal to C cos C, A cos C, C equal to A cos B plus B cos C. How to prove it? So what we'll do here, length of side we have taken E. So if we write let BC equal to A vector, we are not wrong. CA equal to B vector is okay, and AB equal to C vector. This we can write. Because A vector is along the vector BC only, and length is A only, so BC must be A, C must be B, and AB is C. So in triangle ABC, what do you find? BC vector equal to BC vector equal to BA plus AC, and this will imply that BC vector is A, BA vector is what? Minus C, opposite, and this is minus. Therefore, A plus B plus C going to be 0. This is true. Now, what we will do here, you take dot product with the vector C, taking dot product with C. See, right hand side 0 means 0 vector. So what will you get? A plus B plus C dot C going to be 0 dot C. Magnitude is 0, so right hand side is 0 only. This you apply distributive law. A dot C, B dot C, C dot C equal to 0. What about A dot C in the diagram? Just look at the diagram. A dot C. C vector we have taken this manner. Direction of C vector is this way. Direction of B vector is this way. If we take C dot A, then which angle is responsible? Angle between C and A is not B. Instead, angle between C and A is this one, that is phi minus B. So you write A dot C equal to AC cos pi minus. What about B dot C? What's the angle between B and C? Produce it. Angle between B and C is also 180 minus A. Okay? So you write it is BC cos pi minus C. C dot C is what? Mod C square. Okay? So you can write Therefore, minus AC cos B minus BC cos A plus C square 0. So this implies you cancel C from all and then transfer it on right side. It will be A cos B plus B cos A. Done. So we have proved third one. Now you take dot product with the vector B. You can prove second one. Dot product with the vector B for this one. Similarly, you take dot product with the vector A with this one to get this. I'm not going to do all those, just get the concept. And one more important thing here, that cosine law, we can prove it very fantastic way. That cosine rule is what? Let me write first. Cos A equal to B square plus C square minus A square by 2BC. Cos B is what? C square plus A square minus B square by 2AC. And cos C is what? A square plus B square minus C square by 2AB. Okay? See how to get it. That same triangle will be taking here. ABC. Angle, length of sides remains the same. This is ABC, ABC. This one is A, this one B, this one is C. Okay? And you can write A plus B plus C equal to, just to have seen, because we are taking this one A, this one B, and this one C. So we are going to prove cosine A equal to this thing. How to prove it? Cos A, the angle between B and C. So we will be keeping B plus C on the left side and minus A on the right side. Okay? Now squaring both sides. This is important. Squaring both sides means, can you make square of vector the way you do in case of scalar? No. You have to take modulus and then take square. We take modulus. Taking modulus, you get mod B plus C equal to mod of minus C. Now squaring. Mod B plus C square equal to mod A square. So now write mod B plus C square is what? Because we have seen in one of the observation, mod A square is nothing but A dot A. We have seen that. We are going to apply it here. Okay? So you just write or B plus C dot B plus C equal to A square. This is B dot B plus B dot C, C dot B plus equal to A square. Okay? Clear? So B dot B is what? Mod B square, and this is commutative property valid over there. You can write C dot B equal to B dot C. So this will be twice B dot C. Mod C squared equal to A squared. Mod B means B only. Isn't it? Now, B dot C going to be what? This part you have to simplify. See again B vector directed this way. C this way. So we'll be taking this one. Pi minus A over there. Okay? So you write this as mod B square is B square twice BC cos pi minus a b square two bc cos a, you are getting b square plus c square minus a square. Okay, so that cos a going to be b square plus c square minus a square by 2bc. All right. So this we have done for cosine of angle A, which is nothing but b square plus c square minus a square by 2bc. How do you find cosine of angle B? The same manner. Cos B, when you are going to find, you shift B vector on right side, then take modulus of two sides and then make squares. Okay? So all these, that cosine rule formula also can be devised by using dot product of two vectors. For your descriptive paper in boards, you need all these things in dot product. Okay? Now we'll find one very simple application in geometry. How to prove that angle in a semicircle is a right angle. Very good application of dot product. Semicircle we take here. I think I need not explain angle in a semicircle. It means if AB is the diameter of the circle, we have taken the half circle and then we join take arbitrary point P. P and PB you join, required to prove angle APB equal to 90 degree. Okay. I did not show the center. Center is there definitely. We take the center O over there. To prove APB 90 degree, we take position vector of all 3 points. But there is an advantage here. If we have taken position vector of A, we are taking O as the origin. O the center of circle, origin, let OA vector equal to A. Then OB vector, this is the advantage you can take because they are same side, just opposite direction. If this one A, this one has to be minus A. Then OB vector is minus A. What about OP vector? That OP vector is going to be, let us take, this is not given, so let OP equal to R. Do you find any similarity among these three, A, minus A and R? Their moduli is the radius of circle. So you can write, obviously, mod A equal to mod minus A, it will be, and this is mod R. Okay. Now you all have done position vector and how to express a vector in terms of position vector of the end points. We have taken position vector of A as A here, you can see P as R and B as what? Minus A. This one A. So you all can write here PA vector equal to position vector of A, this endpoint, minus position vector of P. Position vector of A is what? That is A minus R. So PA equal to A minus R. PV vector is what? Of B. Position vector of B is minus A and this is minus R. So let us write PA dot PB now. Now PA dot PB going to be what? A minus R dot minus A minus R. You take minus sign common and keep it here. It will be R minus A dot R plus A. Okay. If we go by the distributive law, it will be R dot R plus R dot A dot R, A dot A. R dot R is what? Mod R square. A dot R dot A, they get cancel. Mod A square. So mod R square minus mod A square. How do you write? We have seen that mod R equal to mod A. So this is going to be 0. Therefore, we get PA dot PB equal to 0. This implies that PA perpendicular to PB. Okay? That PA must be perpendicular to PB because dot product 0. So, this very good application will encourage you to prove some other geometric applications also. In a descriptive paper, if you find it, and remember, one thing is very important, whatever you are doing for descriptive one, the concept applies here, equally applicable for solving MCQ. Okay? Now, just let us find one more application and then we'll leave this session. That is to prove that altitudes of a triangle are concurrent. I mean, they pass through the same point. Altitudes of a triangle are concurrent. ABC is the triangle. If we draw 3 altitudes, AL, BM, they are meeting at this point. Say the point is O. Okay? O is the point where 2 altitudes meet. You have to prove that if we join C2O and then produce it, this has to be perpendicular. This is geometry proof. And you have to do it elaborately in geometry, but here in vector, this is very easy because I just told you in the previous applications how to take the vectors along BC, CA and AB. In proving properties of triangle cosine rule, we have done it. And the concept of position vector we have applied in geometry one problem. This is a mixed problem of geometry, trigonometry, whatever you say. But I'll say that I'm applying still dot product in geometry. But the way we have taken in case of proving cosine rule or projection formula, we'll be applying same technique. So both the concepts are required. You'll be taking this one as a vector, there is no harm. this one as B, and this one as C. Okay? Let O be the origin. Or instead you take one thing, don't take that. I'll suggest you take this. Change little bit. Let O be the origin. You assume that O be the origin. O is what? O is the point of intersection of two altitudes. Points of intersection of AL and BM. Okay? You have joined CO and then produce it to meet AB at N. Required to prove CN perpendicular to AB. We want to prove this. What we are taking here, point of intersection of AL and BM as origin. Let O be the origin. And you take OA equal to A, OB equal to B. Okay? To prove this, we are assuming. You cannot say that we are taking which coincides with the proof only. No. We have taken O as the origin, then taken OA as A, OB as B, and OC as C. Now, we have seen that AL is perpendicular to BC. Isn't it? What is BC vector? Here, BC vector is position vector of C minus B, that is C minus B. What is AL vector? AL vector as AL is collinear with which vector? AO vector or wave vector. So we can write let AL equal to M into OA. You can, M may be positive or negative. So this is going to be M into A. Clear? Similarly, BM is perpendicular to BO, and also BO and BM are collinear. So we can write, therefore, BM vector equal to some scalar, say N into B vector. Hope you don't have any problem in understanding these things. Now apply this thing that as AL perpendicular to BC, therefore AL dot BC 0. So this implies MA vector BC is C minus B0. What do you get from here? A dot C minus A dot B0. What do you get here? Vm equal to NB as Bm perpendicular to AC. Therefore, Bm, what we have taken? Bm NB. NB dot C minus A equal to 0. So this will imply B dot C or B dot C minus. So you take this one number 1 and this one 2. Then you subtract 2 from 1. Just do 1 minus 2. If you subtract, what do you get? So you got A minus B dot C0. What is A minus B? That is BA. And C vector. C vector means what? OC. So you got BA dot OC is also 0. OC is this one. Now MC is collinear with OC. So if OC perpendicular to AB, produce part also perpendicular, hence the proof.